Okay, so we're going to talk in this lesson about exoplanets. An exoplanet is a planet outside of our solar system, but still in our galaxy, that usually orbits another star. So this is an exoplanet, is a planet that's outside of our solar system. So we've talked about the planets that are in our solar system. These are planets that are not in our solar system. Usually they're orbiting another star, but we're going to confine our discussion of exoplanets to our galaxy, the Milky Way. So how many of these exoplanets have we found so far? Well, to date we've confirmed 4,575 exoplanets. And that's only the ones that have been confirmed. There's still another 7,950 more that are candidates, and we continue and continue and continue to discover more and more and more. Okay? The closest known exoplanet to Earth is called Proxima Centauri b, and it is 4 light years away. Now, that's relatively close in astronomical terms, but it's really, really far in human terms. This is about 40 trillion kilometers away from Earth. 4 light years at this point in time is an unattainable distance for the technology that we have. And so the chances of us in our lifetime, well, you never know, but the chances of us visiting the closest exoplanet that we know of is very, very, very slim. However, just because they're really far away doesn't mean astronomers haven't found really creative ways to find them and to find out a whole bunch of information about them. Okay? So let's look at the methods of discovery. We'll go through this chart line by line. The first detection method is called the transit method. Okay. And in the transit method, when a planet passes in front of its star, the planet will block some of the star's light, and will do so by a measurable amount, by an amount that we can measure on Earth. So a planet passes in front of its star, it blocks some of the light, and we measure that. This accounts for about 75% of the exoplanets that we've found, this method alone. So this is proven to be really, really successful. Okay. Another detection method that we've used is the radial velocity method. Okay. And in this case, orbiting planets, so whenever planets are in orbit around their star, they cause their star to wobble a little bit because of the force of gravity. And what this does, because the star is wobbling, it's moving, that causes an observable shift in the color of the star's light. Now, when we look up at the stars, we don't perceive them to have different colors, but the different colors are there in the light if we were to analyze it using sophisticated tools. This method is about 20% of all the exoplanets that we've discovered. So when you look at these two methods, these kind of account for about 95%. So you know that the remaining two methods are really small. Okay? The third one is called microlensing. So what's microlensing all about? Well, light from a very, very distant star is bent by the gravity of a planet. And so we can detect that, and we have used that to find exoplanets. Not as many as the other two methods. This accounts for about 3%. Okay? And the last method is imaging. And so this is what it sounds. This is basically when we take pictures of exoplanets, okay, using techniques that can remove the brightness of the star. Like, we know that one of the reasons, you know, like, that it's really, really hard to see anything is because it's the sun. Like, if you were to try and take a picture of something passing in front of the sun, it would be really, really hard to get an image of that because the sun is so bright. So anything that passes in front, it's going to be really hard to take a picture. However, there are techniques that can remove that brightness. And you'll notice this accounts for about 1%. So this totals up to 99%. There are a few other methods, but they account for a very, very small proportion. So we're not going to talk about them. So here's some telescopes. These are interesting. There's all kinds of telescopes that are helping us find exoplanets. The first one was the Kepler Space Telescope. Okay, and it was basically refined in 2018. It was kind of tuned up to help us. It alone found 2,700 exoplanets. It uses the transit method. That's the method that the Kepler Space Telescope uses. And some of the data that we got from Kepler, sorry, this is retired. It was retired in 2018. And so it's no longer up in space. Okay, so, but some of its data is still being analyzed, which is really, really good. It's like there's still more data from that satellite pouring in. This was the Spitzer Space Telescope. This one was used between 2013 and 2020, so it's just recently been retired. It wasn't designed for exoplanets, but because the instruments were really well suited to finding exoplanets, it was dual purposed. Okay? This is the telescope that found the TRAPPIST-1 system, and we're going to talk about that in a minute. Here's TESS. TESS is the Transiting Exoplanet Survey Satellite. And so TESS also uses the transit method. It was designed to explore the most common types of stars, dwarf stars. And because of that, it was looking for exoplanets around dwarf stars. So those are just three. An interesting thing has just recently happened in the news, and that's that the James Webb Space Telescope has just launched, and it promises to tell us a little bit more about the exoplanets that we've found, and even probably find more. So because the transit method is responsible for so many exoplanets being discovered, we're going to talk about it a little bit in a little bit more detail. Okay, so about 75% of all exoplanets have been found using this method. So it's very important. A transit is the path of a planet as it crosses in front of its star. Okay, so this picture right here, I put this in on purpose. This is our sun. Okay, and this right here, this right here is Mercury. Okay, so Mercury passes in front of the sun in its path, and this basically, if we were to take a photo of it, this is what it would look like. It's pretty tiny, right, when seen from Earth. And this is really close. Like, this is way closer than any exoplanet. So, just like an eclipse, right, the planet will block some of the star's light. So Mercury is blocking a little bit of the sun's light. When it passes in front, it's blocking a little bit of that. Just like you kind of see in this diagram here. The planet passes in front of its star, and it's going to block a little bit of the light at different spots as it goes along. Okay? It's a tiny, tiny amount, right? So even though the amount of light that's blocked is tiny, right? Consider this picture, this image right here. The effect is measurable, so we can measure this. The transit method can also help to determine if a planet has an atmosphere, as some of the star's light will also pass through and be filtered by gases, giving astronomers even more information. Okay. So when we look for exoplanets, a lot of people talk about the habitable zone. And this is the range of orbits where liquid water is permitted on the surface of the planet. So we know that Earth in our solar system is in the habitable zone. It's just right. But we know that in our solar system, Mars is a little bit outside of that. So liquid water can't exist on the surface of Mars. It's a little bit too cold. And Venus, it's a little bit too hot, right? Venus can't. We couldn't have liquid water. It would boil because Venus is so hot. Okay. Now, sometimes this is referred to as the Goldilocks zone. Okay. And different, just because a planet is in the habitable zone does not mean it will be like Earth. There's many, many planets that are in the habitable zone, but that aren't Earth-like. Okay. But it is one of the key indicators that we look for. One of the most interesting systems, solar systems, that we've found is the TRAPPIST-1 system. Okay. Unfortunately, it's 40 light years away, so we will not be visiting anytime soon. However, in 2017, NASA announced that it had discovered a group of 7 exoplanets orbiting their star TRAPPIST-1. All of the planets are found in the habitable zone. Further study in 2018 revealed that many of the exoplanets around TRAPPIST-1 have water. The planets that are closest to the star have water vapor. Others have liquid water. And the ones farthest have ice. And this solar system has come to be the most thoroughly known aside from our own, because we know a lot about this solar system. And that's kind of our little survey of exoplanets.